All right, welcome back to Foundations of Data Science for Psychology. Today, we are going to start on the very ground floor and talk about just the most basic concepts in programming and the kind of programming that you're going to do as a data scientist in psychological science. So what we're trying to do here is programmatic data analysis. We're analyzing data using programming. So what does this involve? When we're doing programmatic data analysis, what we need to do is tell the computer what to do in some step-by-step fashion using a programming language, using a language that the computer can understand. So we're giving it a set of instructions in a language that it can understand. And the languages that we're going to be talking about in this course are Python and MATLAB. They are object-oriented scripting languages. So let's talk about what that means. So what is object-oriented programming? What does it mean that a language is an object-oriented language? Object-oriented programming is a programming paradigm that's based on the concept of objects that can contain data and procedures. So it's about creating objects and then manipulating them. So objects can be data stored in some format. Data formats can include things like vectors, lists, arrays, data frames, matrices, and we'll talk about all of that in the upcoming lectures. So data in some format, and then behavior written as procedures. So commands, functions, scripts, basically instructions, what to do. So data and what to do with it. Those are the objects in object-oriented programming. You can think about this as, the data are like things and they're stored in some format. So things in bins. The bins can be shaped differently, formatted differently, structured differently, but fundamentally there's data and that data is stored in some structure. And then what the behavior is what to do to the things. So things in bins, what to do to them. So let's say you have bins full of school supplies, and then what to do to those things. What are the things that you can do to school supplies? Let's say you want to count the number of markers and then divide the number of markers by 2. So that's a behavior that you could define, that you can do to something that you have. The things in bins in the context of programming could be like data stored in a list, like X equals the list containing 1, 4, and 6, so a group of numbers. And then what can you do to that list? Let's say you want to find out how long it is. What is the length of X? And you would write it like that, length of X. Or X divided by 2. What is X divided by 2? Can you even do that to a list? Another way of thinking about this is that the things, the data, objects are like nouns, and what to do to the things, the behavior, are like verbs. So the objects in object-oriented programming are like nouns and verbs. They're the stuff that makes up the language. And let's take a second to talk about what a scripting language is. So it's sort of a helpful distinction to talk about the difference between scripting languages and other kinds of programming languages. So non-scripting programming languages are used to build and maintain applications on software. So actually like developing software and building things. This is probably not the kind of programming that you're going to do as a data scientist. Maybe you will, but that's not what we're talking about when we're talking about data science. So scripting languages are a subset of programming languages, and so it's helpful to be specific. We can kind of say the word programming, and that can mean a lot of things, but what we're really doing is we're scripting, we're writing scripts. The scripting languages are designed for writing and executing scripts. What's a script? A script is a set of instructions for how to process and manipulate data. And in a lot of scripting languages, this is done at a relatively high level of abstraction, meaning that the way that these scripts are written, the languages themselves are pretty close to human language, right? You can see this script down here. It's not in language, it's not in human language, but you can kind of maybe see what is meant by these sort of terms and expressions, because a lot of them are borrowed from English, right? It's kind of comprehensible. It's not ones and zeros. You're typing with words and you're giving instructions with words and expressions that are not that unfamiliar to us. And this sort of makes it kind of beginner friendly and easy to get into. So what we're doing is we're scripting, and R, MATLAB, and Python are scripting languages. That's different from other kinds of programming. So scripts are ordered sets of instructions. So just to take an example, let's say that you are doing market research on cheese, and you want to know what is the average weight of blocks of cheese sold at a particular cheese store. This is a very important problem. So how might you write a set of instructions for how to get that information? Let's say that you have on your computer a file, a CSV file that has data that you've collected from cheese stores. So you want to first open the file. You want to save the data in that file to an object, and you're going to call that object CheeseDat. And so now everything that was in that CSV file is in an object called CheeseDat, and you can manipulate and do things to CheeseDat. So you can ask, how many columns does CheeseDat have? How many columns are in this data object? Which column in CheeseDat is called weight? So you want to find the column in CheeseDat that's called weight. You want to calculate the mean of all the values in the column weight. So what is the average weight of cheese that's in the weight column? And you might want to call this new variable average weight. You could also create a new column called price by weight that calculates the cost per ounce of cheese, right? So let's say you want to add a new column that's a calculated column, where if you have a column that's has the weight of cheese sold and the price of it, you can calculate a new column that has the price per weight of each of those pieces of cheese. So this is sort of how you might tell a human being to do this. This is a set of instructions. So these are the instructions in English, and then this is how you might write those instructions in R, for example. And so this is a script, and you could call this script cheeseweight.r, right? So this is a set of instructions that you now have on your computer. You can open it up and you can run it whenever, and you can calculate the weight of cheese whenever you want. So the way that the expressions are written is a little different from English. The way that you refer to objects and data objects and sort of give commands is a little bit different, but essentially we're writing a list of instructions, and that's what a script is. And to do that, you just need to understand a little bit about the grammar of the language that you're using. So let's talk about some of the programming languages that we're going to use, specifically R and Python. So what do these two languages have in common? They're both scripting languages. They're both open source languages. So that means that anyone can develop new tools and components, and you can download these languages for free. So they're freely available on the internet, and anyone in the world can add and contribute to them and sort of create new content for them. What makes R and Python good for beginners is that the syntax, the grammar of them is relatively simple, uses lots of English words, and it's sort of not that difficult to understand. It's not that complex. It's not ones and zeros. You're writing things that look almost like sentences or mathematical expressions that you're probably already familiar with. And these two languages are widely used in academic research and data science. So most people who do research in psychology or neuroscience use R and or Python, often both. So you'll be able to share, work with people, and collaborate with people. These are sort of the lingua franca of a lot of data science, and especially in psychology. Another thing that's really great about these two languages is that there's tons of libraries and packages available. So what's a library and a package? A library or package is a downloadable collection of pre-written code, so code that someone else wrote. And so you don't have to write it. It's, groups of functions and tools for your programming toolbox. You can download it and then it's sort of ready to go. So you start off with sort of an empty toolbox and you download libraries and packages and you sort of fill up your toolbox with tools. So you don't have to write everything from scratch. There's people out there who have sort of created things for you to use. And because these languages are open source and because so many hundreds of thousands and millions of people use these languages, there's tons of great content out there. So if you are encountering a problem, it's very likely that someone else has encountered that same problem and they may have already written something for you to use. Now let's talk about some of the differences. So what R is really good for is it's specialized for statistics, data analysis, and data visualization. It's sort of very much a data analysis software. There's a very sort of intuitive development environment. So meaning that the software that you use to work with R is sort of easy to use. It makes sense. It's not that complicated. And it's really a sort of a professional standard in experimental psychology. So most psychologists use R. Python also is great for data analysis. It's a great general purpose language. But in addition to being good for data analysis, it also can be used to do some degree of software development or the development of applications or other projects. So R is sort of very specifically for data analysis and statistics, and then Python is a little bit more of a general purpose software. It can be considered a programming language in addition to a scripting language. It's really versatile. You can do so much with it. That's why it's considered a very good sort of first language for people. And it has a lot of applications for machine learning, deep learning, and web applications. So if you ever want to develop something that interfaces with the internet, some sort of plugin, Python is a good way to do that. MATLAB is the third language we'll talk about in this course. The difference between MATLAB and R and Python is that MATLAB is not open source. It requires a license, which you have or you may have as a student. It can be expensive if you don't have a license that is purchased by your organization or institution. But MATLAB is sort of a professional software that's used by engineers and researchers. It's used a lot for neuroscience. It's used a lot for doing sort of engineering analyses. It has really strong mathematical engines. It can do really complex kinds of calculations. It can, of course, be used for statistics and data analysis the way that R and Python can be, but what MATLAB is really built for is matrix computing and signal processing. So those are kinds of computations that are more relevant if you're trying to analyze data from the brain, from neuroimaging, from EEG, physiological data, time series data, or if you have some more sort of biomedical engineering applications to your research. So MATLAB is a little bit more complicated in that way, but the syntax and everything about it, sort of the way that you write code in MATLAB is very similar still to R and Python. Okay, so let's keep defining some key terms. What is syntax? Syntax in natural languages, so human languages, refers to the system of rules that govern the way words combine to form phrases and phrases combine to form sentences. In other words, the syntax of a language is its grammar. It determines what's considered grammatically correct in any given language. And syntax, the syntactical rules differ between different languages. What's grammatical in one language may not be grammatical in another language. So it's sort of the order of words, the way that words combine to form phrases and sentences, and how meaning is extracted from strings of words in the language. So sort of what word order is considered grammatical and how the words in some phrase or sentence relate to one another. In natural human language, word order matters. Some word orders are considered grammatically correct in English. Some are not grammatically correct in English, but are grammatically correct in other languages. So the the boy chases is not a grammatically correct sentence in English, but the boy, the cat's cases, that doesn't make any sense. Those are words that don't go together, that don't create meaning. In English, the phrase he loves her is correct. The phrase he, her loves is not correct in English, but that's the order, that's the word order that would be considered grammatically correct in Japanese. And just as in natural languages, punctuation and formatting matters for computer language. So let's look at some examples, right? There's a difference between let's eat grandma and let's eat, comma, grandma. Let's eat grandma. Are we eating grandma or are we telling grandma let's eat? The difference between something that's in quotation marks and not in quotation marks matters in human language. It also matters in computer languages. So the difference between a security guard or a security guard in quotations, right? A little chihuahua. How you group words and how you format things also matters, right? So toilet only for disabled, elderly, pregnant children, right? That's funny. Is it for children who are pregnant, elderly, and disabled? Or is that meant to be a list that has commas, or if the formatting was different, you would interpret it differently? So these are funny mistakes. These are ways in which punctuation and formatting matters in human language. The same is true in computer language. So syntax in computer languages are the rules that define the combinations of symbols, statements, and expressions that are considered correctly structured in that language. So it really has the same meaning as in natural languages. In other words, which words, symbols, operations, and patterns the language considers valid, and that the sort of are comprehensible by the language and therefore by the computer itself. So getting a syntax error when you're trying to write something, write a script where it says there's something that's invalid about the syntax here is really just the computer saying like, huh, I don't know what this means, right? So it's not that you are doing something wrong necessarily, it's that you're not communicating it in a way that it can understand. So some takeaway points from this quick video. R, Python, and MATLAB are object-oriented scripting languages. Object-oriented languages are a particular class of programming language, and scripting languages refer to a specific kind of thing that these languages do. They write scripts. Scripts are instructions for processing data. They're sort of savable documents or sort of list of instructions. The objects in object-oriented programming are the data, the things, and the behavior, the commands and expressions for what to do to the things. The syntax refers to the grammar of a programming language. These are sort of what word order, symbols, operations, patterns, and combinations are considered grammatically correct in that language. And you will learn the syntax of these languages through instruction and practice. So you will pick this up. We will provide very specific instructions about what is considered correct syntax in these different languages. And then as you practice over time, you will come to understand sort of what's allowed and not allowed and how to communicate with your computer with these languages.